Hey guys, this is Abhay Sharma and welcome to another tutorial. In this tutorial, we are going to take a look at controlling object colors or cycles materials basically from animation nodes. Few weeks ago, I got a mail from Tobias and also few people in the past about changing colors per object instance based on certain property like position or rotation or something like that. So in this tutorial, I will hopefully clear the confusion around color manipulation in animation nodes. So first of all, let me set up a simple scene here. I have tried to turn on the screencast keys, but because I'm using the material viewport shading, it's causing a lot of crashes, so I have to turn it off. Sorry for that. Alright, so let's apply some colors. I'm gonna switch my viewport shading to material so that I can see the changes in real time. Oops, not the ground. Let's select the cube object. So you can see that I can change the material in Cycles Material Editor. But what about changing colors from animation nodes? So let's go into animation nodes and create some color nodes. So in this tutorial, I'm going to talk about set vertex color, combine color and mix colors. Right now, let's focus on the set vertex color node. So to set the color, select the object and change the color, but as you can see that it doesn't have any effect on the object. Why is that? Well, this set vertex color attaches a vertex color attribute to the object, and to see the effect, you have to connect that specific vertex color attribute to the cycles material. So let's go into cycles and create a attribute node first. We have to type the exact name of the attribute. It's COL. Type the name and connect color to color. And now it's working. I can control the color from animation nodes. If I turn on the render preview, sometimes it doesn't work because animation nodes execution stops, but we can see the effect in real time in viewport shading, in materials viewport shading, so it's not a big deal. So this is a single object. What about multiple objects? Let's create a few instances of this object. So let's create an instance node and generate few instances of this cube object. Let's move these two nodes out of the way for now. Let's create a distribute matrix node and change the mode to linear. Connect it to the instancer, it will automatically insert a list length node. So now the instancer knows how many copies to create. Create a matrix output node. Connect the objects to objects and matrices to matrices. I'm gonna turn off the original object and also hide relationship lines. Change the size to step and increase the distance value. That's the actual distance between each object. Let's move all the objects above the ground. For that we can use a offset matrix node. Activate location and move objects in Z direction. Alright, so now we have 5 copies of cube object. Let's try to change the color of each cube separately with vertex color node. Select any cube and assign to set vertex color node. I'm gonna leave this one as it is. Let's duplicate the vertex node. Select a different cube and try to give a different color. You can see all cubes are getting affected. The reason behind this is that these cubes are instances and all instances are sharing the same color attribute. We need to give each instance a unique vertex color attribute. To activate that feature, we have to turn on the deep copy option in instancer node. Let's turn on deep copy and assign different colors on different instances. Now it's working. So far, so good. We can also use other nodes to select specific instances and change color, like If we have list, we can use the get element node to get a specific object based on the index. We can also use single set vertex color node to change multiple objects output if we use loops. So I'll go through each object, connect object to object, and now we need a color list. So create a color list iterator, connect it. We can quickly generate a color list if we select data input and choose color list. Let's add few more elements and now choose whatever color you want. Something like this. Alright, so this is simple, right? Let's go one step ahead. Change colors randomly. Well, there are two ways I know. One, you can do that directly inside Cycles material editor. So let's see that first. I'm gonna turn off the deep copy because I do not need it right now. Switch to Cycles material editor and create an object info node. We can use this random property to randomize the colors per object. So let's create a hue saturation value node and randomize its hue property. Let's change the color to something other than white. And we can also use factors to control the effect of the randomization. Alright, let's see the second option. Connect the color attribute back. And let's go into the animation nodes. Let's loop through each object, and now we're gonna need combine color node. So let's bring it here. Connect object to object and color to color. And before we forget, let's turn on deep copy. Combined color node gives you option to control the color channels individually, like this. Now we can use a random number node to randomize the color values. So let's create a random number node. Connect the index to seed so that each instance will get a different random value. It will generate random values between 0 to 1, and that's perfect for our use. Connect it to any channel. To change the randomization pattern, we can use node seed. I'm going to increase the number of cubes, and you can see that it's all dynamic. Let's experiment with different channels. Green, blue. You can also use the same random node for more than one channel, or if you want, you can randomize each channel individually. You can also use different color models, like right now we are using RGB. I can switch to HSV if I want. Alright, let's talk about the gradient colors. To use gradient colors, we gonna need mix colors node. So bring it here. Connect color to color, and I'm gonna change color A to pure white and color B to pure black. We can use factor to basically mix the colors based on a certain value. Let's connect it to the index so that each instance will receive a different but linear factor value. I don't know if it makes sense. You can see factor need a value ranging from 0 to 1, but index is giving values from 0 to 8 because we are looping through 9 objects. So we have to somehow compress the values or normalize the values between 0 to 1. To do that, we can use a map range node. Let's turn on the clamp factor just to be sure that it will receive values only from 0 to 1. So let's create the map range node. Our minimum number is 0 and maximum number is 8. If you see the iteration value output, it's 9, which we can use it for our max number. You can subtract -1 if you want, but it's not a big deal. Connect the iteration to input max and index to value, and leave output minimum and output maximum to 0 and 1. Now let's connect the value to factor and we'll get a gradient. Now we can change color values and create multiple mixed color nodes here to create multiple color gradients, but I would suggest you should use Cycles material editor for this because it has better nodes for that purpose. So let's switch to Cycles, and I'm going to delete these nodes. To control the gradient, we can create a color ramp node from converter menu. And now you can assign any kind of color gradient you want. Just play with colors. And you can see we have a very precise control over this. Alright, let's talk about the coloring objects based on dynamic properties like position, rotation, scaling, speed, or something like that. So let's disconnect it and move it over here. I won't delete it because we're gonna use it later. Color ramp is still active, so I'll go into Cycles and disconnect it. Now it's okay. So for this example, I will apply colors based on the location or position of the objects. And right now each object has a different location value. But I want to make it a little bit interesting, like objects positioned in a sine wave pattern. So we already have offset matrix node, which we can utilize to manipulate the z position of each object based on the sine wave distribution if we use Falloff property. So in Falloff menu, we have lots of Falloff methods. There is no sine wave Falloff, so we have wiggle Falloff which we can use, but I want a sine wave Falloff. So for this, I'm going to create a custom Falloff node. Now this Falloff requires a float list of different strengths. So I'll generate a float list, and for that I'm going to use a simple loop. Add a generator output, a float list. Let's rename this loop to sine wave. Now we can use a math node and change its mode to sine, and connect the result to float and index to sine input. Press W on the loop node and choose create invoke node. Now we have to connect this to our tree. So first we need to know how many times this loop has to be iterated. For that I will connect it to the list length and connect the loop output to strength of custom Falloff node. Now we can multiply the index value to control the frequency of sine waves like this. We can also use another math node and change its mode to add and use this value to basically offset the values which I will use to animate. So let's create a time info node. It's very fast right now, so let me multiply it by 0.1 to make it 10 times slower. We can use the z value to control the amplitude. I'm gonna set this to 6. So now we have something interesting. Let's apply colors based on the location of the objects. So first of all, I'll show you how you can use the logic nodes. Then we'll use the map range node. So for this to work, we need location list of the objects. We already have the matrices which has location, rotation, and scaling information. So to extract the location data, we can use a decompose matrix node. Translation, location, same thing. We need to get this data in our loop, so let's create a vector list iterator. Connect translation to vector list. We are going to apply the color based on the z position of the object, so we have to separate the vector. So for that we can use a separate vector node. You can also do this before entering into loop, but it doesn't matter for this example. Now we can compare the object's z position if it is more or less than a specific value. Based on that result, we can assign a specific color. So let's create a switch node and change its type to colors. Connect result to condition and switch output to colors. I'm gonna change one color value to pure white and other to pure black. You can see the effect. These numbers are in grid units. This is a very powerful way to exactly control the colors however you want. Let's use our map range and mix color node to get gradient colors. Connect the z value to value and let's set the maximum value to 6. You can set the minimum value to -6, but I'll leave it to 0. So it will affect only those objects which are above the grid. Now we can use our color ramp node in Cycles material editor. Let's play with colors a little bit. We can dynamically control the color's intensity. Just experiment with different values. Let's increase the number of objects. Oops, not that much. Let's say 50 objects. Or 10 or 20, or let's say we need different distribution like grid. Something like this. Let's change the pattern a little bit. Looks interesting. Let's adjust the colors a little bit. I hope you get the idea. And this is just positional data. It could be anything, scaling, rotation, or custom, or any custom attribute. Now the last thing I want to talk about is controlling other attributes of cycle material other than colors. So in animation nodes we have a specific node to control the cycles material output, but there is no option for assigning this node to any object. But we can use this node to control a specific cycle material property. For example, we can control the color of ground plane material. But how about applying this shader to every single object uniquely? I don't think we can instance cycles material in animation nodes, but what we can do is we can exploit Vertex Color node to export data from animation nodes to cycles material editor for controlling other properties rather than just controlling colors. So basically colors is a group of data, right? It has a group of float values. We can send normalized values from animation nodes using Vertex Color node, and then in cycles material we can apply it on any other property, and also we can use other nodes to extract specific channel or apply math operations. So it's pretty easy there. Let's duplicate this Vertex Color node and rename it to something else like ch1 for channel 1. I suggest you should use proper naming conventions to avoid confusions later, but for this demo I'll go with ch1. Let's connect the object to object, and then we can use a combined color node to export different data from animation nodes. I'm going to create a random number node, for example, and it will generate values from 0 to 1. Connect the seed to index, and let's use the red channel. Switch to cycles material. I'll use a different shader, something which has more attributes like principled BSDF. Connect the colors to base color. Alright, now to import the other data we can use the attribute node. Just duplicate this and change the name of the property. In our case, it is ch1, right? To extract the red channel, we can use a separate RGB node from converter menu. Now we can connect this red channel to any property. Let's connect it to something which accepts 0 to 1 just to avoid any math operation right now. How about transmission? You can see that our cubes has turned into something like glass because each instance is getting a different transmission value. Let me turn off the roughness so that you can see the effect clearly. We can also use other channels as well, and we can also create as many vertex color attributes as we want. Let me show you an example. So this is just a simple example where I have connected the scaling of the objects to transmission values. So when objects gets larger, it turns into glass. Alright guys, that's it for this tutorial. I hope you liked it. Thank you so much for watching, and I'll see you next time. Bye bye.